Almond Robotics launched Axol this week as a dual-arm robot built specifically for teams developing physical AI systems that must function in factories, warehouses, kitchens, and other unpredictable settings. The company spent the past year putting existing robots through real shifts in grocery stores and production lines. Those machines repeatedly hit limits that slowed progress or caused outright failures. When attempting to insert its hand inside bins or equipment, reach usually fails. Payloads led the motors to overheat for extended periods of time, and the exposed cables were repeatedly bent until they broke. Singularities would regularly intervene, requiring the robot to slam on the brakes or perform more maneuvers to get back to a safe position. Even more frustrating, it would take forever to collect clean, labeled demo data, because the robot couldn't seem to approach the task in the same manner that a human operator would. Axol grew out of those hard lessons. Almond designed everything with long-term, contact-rich work in mind, and he devised a technique to accelerate data collection for training in the event that a human operator was absent. Each arm has 7 degrees of flexibility and extends 860 millimeters from shoulder to fingertip, providing a robot with substantially more workspace than identical research arms without the need to reposition the base every 5 seconds. The wrist joints alone can perform full 180 degrees of pitch and yaw, giving the robot plenty of flexibility and reducing any annoying singularities that would normally limit the usable workspace on other platforms, all of which adds up to smoother trajectories when the robot is attempting to reach for something complex. Payload peaks at 6.5 kilograms, and in typical operation, the actuators can support a steady 4-kilogram weight without ever throttling back owing to heat. That level of sustained capacity is essential for tasks that include frequent lifting, pressing, or tool use. All of the cables inside the item are routed internally, so there's no risk of them catching on anything or wearing out due to frequent movement. 2 FACRA GMSL 2.0 connections are neatly positioned at each wrist, ready to be connected to high-speed stereo cameras that deliver low-latency vision where it counts, precision grabbing, and insertion. Standard grippers include 2 fingers and interchangeable tips, and because the technology is modular, teams can easily swap in custom end effectors as projects progress without having to start over. The control loops operate at a constant 500 Hz, which is necessary for responsive, fine-grained movements, especially when dealing with delicate touch operations. Axol delivers the robot directly from Almond's workshop in San Francisco's Dogpatch district, which is advantageous for a number of reasons, including faster part availability and on-site maintenance options for Bay Area deployments. Just as important, the software stack is given equal attention. The full solution is accessible as an open-source Python SDK, which includes low-level CAN motor control, bimanual inverse kinematics, Z'd camera streaming, and LaRobot connectivity, as well as a WebXR teleoperation pipeline for any compatible headset. The system records everything, including synchronized joint positions, camera frames, and actions, in policy training-ready formats. Since Almond is addressing startups and research groups, pricing is modest. Hence, the standalone Axol is listed at $7,999 during the launch window. The set includes a height-adjustable mobile platform, 3 ZX1S cameras, an NVIDIA Orin NX 16GB computer unit, and all necessary cables for $11,999, which includes shipping. Both options are available currently.